of wave. So what is called interference? So the effect of superposition of two or more wave from a coherent source of wave. Okay, coherent means that it has same phase. Coherent means that same phase, or we say constant frequency and constant wavelength. Then we call this wave coherent. So when two of them combine, it can be like this one is an increase in amplitude from A and A become 2A. But if destroy, there might be some destroy as well. Okay, so the two sources of wave which produce wave with the same frequency, same wavelength, and phase difference is constant. Then we call it as coherent wave. So for superposition, when two waves move simultaneously and coincide at a point, coincide at what means this one. Okay, the touching of 2 points. The resultant displacement is the displacement is the sum of the individual displacement of the two waves. So like I said, A and A, like this one, you see if this 2 point is the same, they touch in here and here. So it will become 2A. Now, let's say if one is A, one is negative A, so they will cancel out each other, so become cosine during that point. You understand? So this addition and destroy are both considered as a superposition. Okay? All right, note this down. Okay. Done up. All right, now let's continue. So the effect of superposition of two-wave crests or two-wave probes of coherent source will generate the maximum amplitude. You see, crest and crest when combined here, it becomes 2 alpha. Trough and trough combined at this point, it will become 2 alpha as well. But if this one is constructive, destructive interference is when the crest and trough from a coherent source produce a zero amplitude line. Both go here and here, so they cancel out each other. Become like this, nothing happen. So this one is destructive interference. While anti-knot is a point where constructive interference occur. Like this one, this point is the what you call anti-knot. Knot is the point where destructive interference occur. Okay, all right, jot this down. Nah. Okay, so let's see some experiment on the interference of water wave. So the inference, the distance between two consecutive nodal lines depends on the distance between two coherent sources. So hypothesis, the distance between two consecutive nodal lines x increase as the distance between two coherent sources decrease. Means that as long the nearer two sources together, okay, So the distance between the consecutive nodal line will increase. Okay, so let's see. So this is how we do the experiment where now dipper last time only have one. Now we put two dipper where they will create the interference in between them. Okay, so this is how the red color and the blue color one will interfere each other. So okay, so the nearer these 2 points, okay, the gap between these I mean the gap between like this point and this point here will be farther away. Will be the nearer they are, the further away this one will. Okay. Now next, the interference of light wave. So okay, they are using the experiment like, okay, we are using one laser light source, but with two slit, double slit. So after that, you will find out that the slit, the color will show like this. This is the bright side. This is the constructive one. This is the dark side, which is the destructive one. Okay, so the what I call the hypothesis between them is when the distance increase, the wavelength decrease. Okay, so then for the third one experiment, they will use where when the point between the x is increased, the distance between the listener and the two loudspeaker will increase as well. So the experiment is do like this. We have two loudspeaker, and then we determine we move the what I call, the listener will move front or backward. Okay, until you see how they do until they saw he listened to the increase of the loudness. You understand? Normally, if you move left and right, it's not the interference point. You won't feel that the sound is very strong unless you are at the what you call the anti-nodal and nodal line. Anti-nodal, the sound will go very strong. Nodal line, but the easiest way is by nodal lines. Nodal line that you in short, you should listen to anything. You shouldn't listen to anything because cancel out each other. Can you understand? Can you understand? Okay. So so I want to ask you to this is the one that you should learn. So in terms of Young interference formula, the formula lambda is equals to AX over D, where A is your what I call the distance between the two coherent sources. X is the distance between the nodal line and this is the nodal line. Okay, or this one also can anti-nodal. This one also considered as X. Okay, and D is the perpendicular distance from the two sources. Okay, to the point of measurement. Like this one, here is the measurement point. So in between this one to this one is D. Okay, where the dotted line is the what you call the negative, solid line is the positive. Okay, so how they draw this is by, like, you see this one, this is the nodal one, anti-node are the what you call that, the constructive line. So anti-nodal here, anti-nodal here, anti-nodal until one point. So they draw like this. This one like anti-nodal draw. So the point where you see this one combined, so it's a straight line. Then for the northern line, you see plus, you see plus minus, see cancel out each other. So 1 point, 2 point, 3 point. So it becomes like this. Understand? This is how we draw. Okay. All right, jot this down. This one, and this one. The side one, no need. The side one I already showed you how to draw this. So you doesn't need to draw this one again. Do not waste your time. Done, huh? All right, then. So let's see the applications of this interference of waves in daily life. So for example, the large ship has a structure of bulbous bowl. Okay, the bulbous bowl which generate the water wave that interfere destructively with the water wave around the hull. So this is the hull. The bulbous bowl looks like this. Okay. So this will cause the water around the ship to become calmer and reduce the water drag. Okay, most of the big ship you will saw there's a one big thing at the bottom of the hull. Okay, and then anti-reflection lens. Okay, has a coating on the surface to reflect the light to interfere destructively. This is to prevent any that image form on the lens to get a clearer vision. And your headphone that used by the pilot, they have a microphone and transmitter system which produce sound wave which interfere destructively with the surrounding noise. Same goes to your this one is different. The anti-noise normally the noise headphone that we use, they are actually using the what I call like they are using this kind of like fabric to absorb the extra noises. The noise one is different, is connected to power where it will release the certain frequency or certain wavelengths sound wave to cancel out each other. Okay, so that they can receive all the what you call that, the transmission from the control center, all this. Okay, all right, got this down. All right, so let's do some homework. Try these questions. I thought it should be have six. Wait, I think we should six questions. Let me. Uh, I try to do these four questions. Yeah, I forget my handphone again.
அன்னைக்கு மழை பெஞ்சது உண்மையா பயமே இருக்கு விஷயமா வீட்டுல சவால் எங்க அப்பா எல்லாம் கும்பல போயிட்டாங்க Input is 1 time. And then 7 0. And 0.96. Okay.
Okay.
So far,
Done? No, yeah. Done. Okay. So we discussed these 2 questions first. 4 questions, sorry. Actually, I think we have a total of 6. Okay, so let's see the answer. So now, in an experiment to investigate the interference to pattern of these water waves, the distance between 2 spherical dipper is 2.5. So means that the A is 2.5, and the distance between 2 consecutive anti-nodal line is 5.0. X is 5.0. So what is the wavelength of the water wave if the distance from 2 dipper to the point of measurement is 10? So lambda is equal to X over D. So it's 2.5 times 5 divided by 10. So you get 1.25 cm. Now, a sonar signal sent vertically downward from a ship is reflected from the ocean floor and detected by a microphone on the keel 0.8 seconds after the transmission. So if the speed of the sound in water is 1005, so what's the depth of the ocean? So we know that the motion of this sonar is it hit the ocean floor, then go back. Correct? So there are total how many D here? 2. Correct? So 2D is equals to V times T. So 1500 times 0.8 divided by 2. So you get 600 meter. Alright. You have to divide because it's a back and forth motion. Okay. Done, huh? So in an experiment of light interference using green light of wavelength 5.10 power of -7 meter, 2 consecutive bright fringe formed on the screen are 0.4 mm apart. So when the experiment is repeated by using the monochromatic light S, 2 consecutive bright fringe form are 0.48 apart. So what's the wavelength? So provided that the green one has the wavelength of this 5 times 10 to the power of -7 meter. Okay, this is the wavelength. And then for green one, the X is just now 0.4 mm. Okay, means that 4 times 10 to the power of -4 meter. and the x for s is 0.48, means 4.8 times 10 to the power of negative 4. So by using this formula, lambda equals to x over d. So for the green one, okay, it's equals to a over d times x for green one. A over d times green. Okay, we know that because a over d are constant here. So a over d is equals to, we move this here. So it's lambda over x. So this is the first equation. Then we know that lambda s is a over d xs. So we move this here. A over d is equals to lambda s over xs. So both is the same, correct? Both are a over d. So we know that lambda green to x divided by x green will be equals to lambda s divided by xs. Fill in all the value and then move this here. So your lambda s will be 5 times 10 to the power of negative 7 divided by 4 times 10 to the power of negative 4 times 4.8 times 10 to the power of negative 4. So you should get 6 times 10 to the power of negative 7 meter. Correct? Good. Then this one, number 4. The diagram on the right shows the fringe pattern obtained in a double slit experiment when a monochromatic light is used. So the double slit are 0.5 mm apart and the screen is 3 meters away from the double slit. So what's the wavelength of the monochromatic light? So given that A is 0.5 mm and then the screen is 3 meters, so D is 3 meters. Okay, now to get X, this one he showed is 1.4. How many? 1, 2. Okay, so means 1, 2, 3, 4, 5. Correct? There are 5 gap here. So we need to divide by 5. 1.4 divided by 5, you get 0.28 cm. Okay, or change it into 0.28 times 10 to the power of negative 2 meter. Then by using lambda equals to x over d, substitute all this inside, you get lambda is 4.67 times 10 to the power of negative 7 meter. Correct? Correct? Okay. Okay. Done. Okay. So let's continue with this. Okay. Try this. Number 5. Can soi? Can see? Clear? All right, so let's continue with the answer. So the diagram below shows two speakers connected to an audio signal generator to generate two sets of sound waves that are coherent. So the audio signal generator is switched on. So a student who walk along the straight line XY here, walk along here, at a distance of 5 meters from the speaker, hear a series of alternating loud and soft sound at point P, Q, R, S, T. So two speakers are separated by a distance of 2 meters. The sound wave produced has a frequency of 1200 hertz with a speed of 300 meters per second. He wants you to calculate the wavelength. So first, we try to get V equals to F lambda. Okay, so V is 300, lambda is 1002. So F is 1002, lambda you get 1002 over 300 over 1002, you get 0.25 meter. Okay, then calculate the distance between two consecutive strong sound. Means that he wants you to find X. So A is provided 2 meter, X divided by 5. Okay, and then equals to 0.25. So you get your X is equal to 0.625 meter. All right, using the concept of wave interference and other appropriate physics concept, explain how the distance between two consecutive loud noise is reduced if the experiment is carried out at night. So at night is cooler, okay? So the temperature drop. So the density of the air will increase. So with this, when density increase, so your wavelength decrease because X is direct and X is directly proportional to lambda. So when your lambda decrease, X decrease. You have to decrease the what you call the distance between the loud noise. Wait, sorry, it will cause the X decrease. Okay, done. All right, now we still got some time, so let's continue a bit. So electromagnetic wave. So electromagnetic wave is transverse wave, consists of oscillating electric field and magnetic field, which are perpendicular each other like that. It's a combination of two waves, and the angle between them is 90 degrees. Okay, one is up and down, one is like this. So the electromagnetic spectrum is a series of electromagnetic waves in descending order of wavelength, or sometimes the ascending order of frequency. So the value is like this. From left to right, okay, wavelength is decreased, but frequency is increased. Okay, you jot this down first.
Sorry. Slow down GMT.
Done, so okay, we see, so this is how it looks like, so your gamma ray falls under this category, then followed by X-ray, microwave, and radio. Okay, my suggestion is you copy this out and try to memorize these three. Okay. Okay.
No, sorry, it's slow down.
It's okay. Done, then you're allowed to dismiss because somehow it's already time's up.